Long before the North Sea existed in its modern form, an immense expanse of land connected what are now the British Isles to continental Europe. This vanished territory, known as Doggerland, occupied a central position in northwestern Europe and played a critical role in human migration, adaptation, and survival during the late Pleistocene and early Holocene. Geographically, Doggerland stretched across the present-day seabed between eastern Britain, the Netherlands, northern Germany, and southern Scandinavia. At its maximum extent, it covered tens of thousands of square kilometers. Rather than a marginal or inhospitable zone, it formed a continuous and habitable landscape, integrated into the broader European landmass. Its emergence was directly linked to global climatic conditions. During the last glacial maximum, approximately 26,000 to 19,000 years ago, vast quantities of water were locked in continental ice sheets. Sea levels dropped by more than 100 meters. As a result, the continental shelf of the North Sea basin was exposed, transforming seabed into dry land. Before we dive back in, let us know where you're watching from in the comments. If you're enjoying the content, hit subscribe. It really helps the channel. And to everyone already subscribed and following Primal Roots, thank you for the support. As the climate began to warm, glaciers retreated, but Doggerland did not immediately disappear. For several millennia, it remained a stable and productive environment. Rivers carved wide channels across the plains, including systems comparable in scale to the modern Rhine, Thames, and Elbe. These rivers converged into a massive drainage network that flowed northward, shaping floodplains, wetlands, and fertile lowlands. From a paleoenvironmental perspective, Doggerland was remarkably diverse. Sediment cores, pollen records, and faunal remains reveal a mosaic of ecosystems rather than a uniform plain. Mixed woodlands of birch, pine, hazel, and later oak expanded during warmer phases. Open grasslands persisted alongside marshes and shallow lakes. Seasonal flooding enriched soils and sustained high biological productivity. This environmental richness made Doggerland exceptionally attractive to human populations. It was not a peripheral corridor, but a core habitat. The abundance of fresh water, plant resources, and animal life supported long-term human occupation rather than transient passage. Faunal assemblages recovered from submerged sediments demonstrate the presence of large herbivores, such as red deer, elk, aurochs, and wild horses. These species, in turn, supported apex predators and, crucially, human hunters. Smaller mammals, waterfowl, and fish were also plentiful, offering year-round subsistence options. Human adaptation to this landscape was shaped by its dynamic nature. Seasonal cycles dictated mobility patterns, but they did not impose instability. Instead, Doggerland offered predictable ecological rhythms. Human groups could anticipate animal migrations, plant availability, and river behavior with considerable accuracy. Archaeological evidence, though fragmentary due to submersion, consistently supports sustained human presence. Stone tools recovered from fishing nets, dredging operations, and coastal contexts reveal technological traditions associated with late Upper Paleolithic and Mesolithic cultures. These artifacts show continuity rather than abrupt change, indicating long-term regional occupation. Lithic assemblages suggest highly efficient exploitation of local raw materials. Flint sources were abundant, particularly along riverbanks and eroding cliffs. Toolkits were optimized for hunting, processing carcasses, woodworking, and hide preparation. Such technological investment reflects a population deeply familiar with its environment. Adaptation in Doggerland was not limited to subsistence strategies. Spatial organization also reflects environmental intelligence. Campsites were likely positioned on elevated terraces near water sources, balancing access to resources with protection from flooding. Although direct site preservation is rare, landscape modeling supports this pattern with high confidence. Crucially, Doggerland functioned as a connective hub. Its open terrain and river corridors facilitated movement between Western and Northern Europe. Genetic, cultural, and technological exchange occurred across this landscape, long before the British Isles became islands. In this sense, Doggerland was not a boundary, but a bridge. Climate fluctuations did influence the region, but adaptation kept pace with change. During cooler intervals, open tundra-like conditions expanded, favoring large grazing mammals. During warmer phases, forests advanced, requiring shifts in hunting strategies and tool use. Human populations adjusted without evidence of collapse or abandonment. The gradual rise in sea level, driven by continued glacial melting, did not immediately render Doggerland uninhabitable. Instead, coastlines migrated slowly, wetlands expanded, low-lying areas were lost, but higher ground remained viable for generations. Adaptation occurred incrementally, mirroring environmental transformation. By understanding Doggerland's location and environmental structure, it becomes clear that this region was not a fleeting anomaly. It was a stable, resource-rich landscape that shaped human behavior over thousands of years. Its eventual submergence would redefine European geography. But for a long span of prehistory, Doggerland stood at the heart of human adaptation in Northern Europe. As Doggerland stabilized into a vast and productive landscape, human populations did more than occupy it. They learned to read it, navigate it, and adapt their behavior to its shifting ecological patterns. This was not passive survival. It was active environmental integration, shaped by long-term familiarity with terrain, climate, and biological cycles. Archaeological and paleoenvironmental research indicates that Doggerland supported dense networks of hunter-gatherer groups during the late Upper Paleolithic and throughout the Mesolithic. These populations were not isolated bands moving randomly across open land. Instead, they formed structured mobility systems, closely aligned with river courses, seasonal resource zones, and topographic variation. Location played a defining role in social organization. Rivers acted as natural highways. They guided movement, facilitated communication, and concentrated resources. Human groups repeatedly returned to specific areas, not because of permanence, but because of predictability. These were landscapes remembered across generations. Lithic evidence recovered from the North Sea basin reveals repeated patterns of tool production and use. Assemblages associated with Maglemosian and related Mesolithic traditions show technological continuity across wide areas of Doggerland and adjacent regions. This suggests not only movement across space, but shared knowledge systems maintained through social contact. Adaptation in Doggerland was fundamentally ecological. Subsistence strategies were flexible and responsive, rather than specialized to a single prey species or environment. Large mammals such as red deer and aurochs provided substantial returns, but they were only part of a broader subsistence spectrum. Fishing, fowling, and the gathering of plant foods played equally important roles. Zooarchaeological data indicate selective hunting rather than indiscriminate exploitation. Age profiles of prey species suggest planned harvesting, aligned with seasonal availability and herd dynamics. This implies foresight and ecological understanding, not opportunistic behavior. Spatial adaptation also extended to settlement patterns. While permanent villages did not exist, occupation was not random or evenly distributed. Camps were strategically positioned near ecotones, transitional zones where different ecosystems intersected. These locations maximized access to diverse resources within short travel distances. Paleolandscape reconstructions, including those developed by archaeologist Bryony Coles, demonstrate that higher ground along river terraces and low hills offered optimal living conditions. These areas provided visibility, drainage, and relative protection from flooding, while maintaining proximity to wetlands and forests, rich in food resources. Human adaptation was further shaped by gradual environmental change. As post-glacial warming progressed, forests expanded across Doggerland. This transformation altered visibility, animal behavior, and resource distribution. Human groups responded by adjusting hunting techniques, increasing reliance on ambush strategies, and diversifying toolkits. Microlithic technology became increasingly prominent. Small, modular stone tools could be hafted into composite weapons and easily repaired. This technological shift reflects adaptation to forested environments, where close-range hunting and rapid response were more effective than long-distance pursuit. Importantly, adaptation was not merely technological. Social organization evolved in parallel. Smaller group sizes during certain seasons reduced pressure on local resources. Periodic aggregation likely occurred during times of abundance, reinforcing social bonds and facilitating cultural transmission. Genetic and cultural continuity across Doggerland and neighboring regions supports the idea of sustained interaction rather than isolation. Studies synthesizing archaeological and environmental data, including work published by the University of Bradford's Doggerland project, emphasize the region's role as a demographic core rather than a marginal frontier. Location also influenced resilience. As sea levels continued to rise, Doggerland did not vanish overnight. Coastlines shifted slowly, transforming inland areas into wetlands and estuaries. Human groups adapted by exploiting aquatic resources more intensively. Fishing technologies, watercraft use, and shoreline foraging increased in importance. This transition reflects behavioral plasticity rather than displacement. Communities adjusted their spatial focus, relocating camps incrementally as environments changed. The archaeological record shows continuity in tool traditions during this period, suggesting that populations remained culturally stable even as their surroundings transformed. Adaptation, however, had limits. As habitable land shrank, population density increased in remaining areas. Resource competition likely intensified. Mobility routes narrowed. Eventually, migration became the most viable response. Groups moved westward into what would become Britain and eastward into continental Europe. This process was not a collapse, but a redistribution. Human populations carried their knowledge, technologies, and cultural practices with them. The legacy of Doggerland persisted in the archaeological signatures of later Mesolithic societies across northern Europe. Scientific understanding of these processes draws heavily on interdisciplinary research. The synthesis of geological modeling, archaeological recovery, and paleoecological analysis has been central to reconstructing Doggerland's human story. Foundational contributions by researchers such as Bryony Coles, along with large-scale projects like the North Sea Palaeolandscapes Project led by Gaffney, have transformed submerged prehistory into a data-driven field of study. Through this lens, Doggerland emerges not as a lost land defined by catastrophe, but as a dynamic human environment defined by adaptation. Location shaped opportunity. Change demanded response. Human populations met that challenge with flexibility, intelligence, and resilience. The disappearance of Doggerland was not a singular event, nor was it an abrupt catastrophe that erased human presence in a moment. It was a prolonged process of environmental transformation, unfolding over centuries, driven by rising sea levels and reshaping both geography and human behavior. Adaptation, once again, defined the human response. As the Holocene progressed, global temperatures continued to rise. Ice sheets melted at accelerating rates, releasing vast volumes of fresh water into the world's oceans. Sea levels climbed steadily, inundating low-lying areas of the North Sea basin. Doggerland began to fragment, What had once been open plains gradually transformed into wetlands, estuaries, and shallow bays. Location determined the sequence of loss. The lowest elevations were submerged first, forcing human groups to shift their activity zones toward higher ground. River valleys widened. Freshwater systems became brackish. Terrestrial ecosystems contracted, while aquatic environments expanded. This was not sudden displacement, but a series of spatial adjustments made across generations. Archaeological and paleoenvironmental data indicate that human populations responded by intensifying their use of coastal and wetland resources. Fishing became more prominent. Shellfish gathering increased. Waterfowl hunting expanded. These shifts reflect a high degree of behavioral flexibility, consistent with long-standing hunter-gatherer adaptation strategies. Technological responses accompanied ecological change. Evidence suggests increased reliance on watercraft, likely simple dugout canoes or skin-covered boats, enabling movement across flooded landscapes and between shrinking land masses. Such technology would have extended mobility rather than restricted it, allowing continued access to dispersed resources. As Doggerland narrowed, social geography changed as well. Migration routes became more defined. The once open connective hub began to channel movement toward emerging coastlines. Groups gradually relocated westward into the British Peninsula and eastward into continental Europe. These movements were not isolated events, but part of a broader demographic redistribution across northern Europe. Importantly, the submergence of Doggerland did not produce a cultural break. Lithic traditions, subsistence strategies, and settlement patterns show continuity across the transition. The archaeological record of early Mesolithic Britain, in particular, retains clear affinities with continental traditions, reflecting sustained population flow rather than sudden isolation. The final severing of land connections occurred around 8,000 to 6,500 years ago, as rising seas completed the transformation of Doggerland into the North Sea. By this time, human populations had already adapted to coastal living. The creation of the English Channel and North Sea reshaped mobility, but it did not erase cultural memory. Genetic evidence supports this continuity. Modern populations in the British Isles retain genetic signatures consistent with Mesolithic ancestry shared with continental Europe. These patterns indicate that Doggerland was not merely a corridor, but a source region, contributing significantly to the genetic landscape of later European populations. From an adaptive perspective, Doggerland serves as a long-term case study in human resilience. Environmental change was continuous, yet populations persisted. Mobility strategies adjusted. Technologies evolved. Social networks reorganized. At no point does the evidence suggest collapse driven by environmental stress alone. The often cited Storegga submarine landslide and resulting tsunami, which occurred approximately 8,200 years ago, likely impacted coastal areas of Doggerland and adjacent regions. However, current scientific consensus views this event as a localized disturbance rather than the primary cause of abandonment. Sea level rise remains the dominant driver of long-term change. Understanding Doggerland requires abandoning the idea of sudden loss and embracing a model of gradual transformation. The landscape did not vanish overnight. It was lived in, adapted to, and eventually left behind through informed decision-making rather than desperation. The legacy of Doggerland extends beyond archaeology. It offers critical insights into how human societies respond to large-scale environmental change. Rising seas, shifting ecosystems, and altered coastlines are not unique to the past. They are recurring forces in human history. By examining how prehistoric populations navigated these challenges, Doggerland provides a scientifically grounded narrative of adaptation rather than vulnerability. Humans did not simply react to environmental pressure. They anticipated it, adjusted to it, and integrated it into long-term survival strategies. Today, Doggerland lies beneath the North Sea, preserved in sediment layers, submerged river channels, and scattered artifacts. Advances in marine geophysics, seismic mapping, and underwater archaeology continue to refine this picture. What was once invisible is becoming increasingly well-defined. Doggerland's story challenges traditional land-based perspectives of prehistory. It reminds us that coastlines are temporary, landscapes are dynamic, and human adaptation is deeply tied to environmental context. Location shapes opportunity. Change reshapes location. Adaptation bridges the two. In this submerged world, human history did not end. It transformed, migrated, and persisted. Doggerland was not lost in the sense of disappearance. It survives in the people who moved across it, in the cultures that emerged from it, and in the scientific record that continues to reveal its significance. The study of Doggerland ultimately reframes how prehistory is understood. It was not a marginal zone erased by nature. It was a central landscape, actively inhabited, intelligently used, and gradually relinquished. Its legacy remains embedded in the human story of Northern Europe. If this research-based documentary deepened your understanding of human adaptation and submerged landscapes, subscribe for more scientifically grounded explorations of prehistory, climate, and human evolution.